Welcome to the next session of ANSYS APDL. In this session, we are solving a numerical of this sort where I'm going to have a cantilever beam. One end is fixed and I can see some point load on the beam. We have already solved this numerical using ANSYS Workbench. Now we are solving this in ANSYS APDL. So let's get started. I'll first go to Preferences, Structural, OK, Preprocessor, Element Type, Add, Edit, Delete, Add, Beam, to Node, OK, and Close. Next, I'll go to Material Properties, Material Model, Structural, Linear, Elastic, Isotropic. I'll choose the value of Young's modulus as 2E5 and Poisson's ratio as 0.3. OK, and close this. Material properties is done. Next, I'll go to sections. I'll choose beam, common section. Let me give the breadth as 50 and the height as 20. This is any random value that you can give. This is done. Next, I'll go to modeling, create key points in active CS. My first node is always at 0, 0, 0. Now, when I go for the second node, I can see here, this is my first node, which is A. The second node is B. The distance is 1 meter, so I'll take it as 1000 mm. Node C is at 2 meters from end A, so it is 2000 mm. And end D is at 4 meters from end A, so it is 4000 mm. So let's plot them. Second node is at 1 meter. Node 3 is at 2 meter and node 4 is at 4 meter. So here are my 4 nodes. Next I'll go to lines, straight line. I'll choose 1 and 2, 2 and 3 and then 3 and 4 and form the entire beam. Next I'll go for meshing. Size control, manual size, global size. Say the number of divisions are 10. You can give any number of element divisions you want. Next I'll go to mesh, lines, pick all. So the meshing is done. I can go to plot controls, numbering. I'll choose element numbers on OK. So here I can see the number of elements on the beam. Next I'll go to loads, define load, apply, structural. Now when I look at this figure, it is given that end A is having a fixed end. So I will choose displacement on key point. This is the first key point. OK, it is fixed. So all degree of freedom 0. OK. Next, I'll go for node B. Here, there is a load of 10 kilonewton in the downward direction. So, I will choose force or moment on key point. The second one, OK. In the Y direction, the value is 10 kilonewton. OK. At node C, there is a load of 20 kilonewton in the upward direction. So I will choose node C. OK. 20,000. OK. And last I'll choose this end point. OK. Here there is a load of 10 kilonewton again in the downward direction. As you can see here. So this completes my loading. Next I'll go to solution, solve, current ls. OK, the solution is done. So I'll close this and this box. Then I'll go to general post processing, plot results, deform shape, deformed plus undeformed. So this is how I can see my deformation in the beam. It's a cantilever beam. Next I'll go to contour plot, nodal solution, degree of freedom, displacement vector sum. I want to see the deformed shape with the undeformed model. So this is how it looks like. Also, if I want to see the stress on the element, I will click 1 Mises stress. Okay, so this is the 1 Mises stress over the entire beam. Now I want to go for the SFD and the BMD diagram. So I will go to element table, define table, add. Here I have to choose by sequence number. SMICS is what I'm going to choose. The first number that I choose is 3. Apply. Again I go to by sequence number. Here I'll choose the number as 6. Apply. Then I'll go to by sequence number 16. Apply. And the last one is 19. Okay. So these are the 4 values which I have to enter. Close. Next I'll go to contour plot. Here in contour plot, line element resolution is what I want to see. If I want to see the bending moment diagram, then for node I have to choose SMIS3, and for node J I have to choose 16 as the number. Okay, so here you can see this is the bending moment diagram obtained. Now this can be checked with this diagram. You can see it is exactly the same diagram here. Now for these values, I'll have to see the colors over here. Once I see the color, I can match and I can see the values from my numerical solution and then just check the values from here. Next, if I want to see the shear force diagram, I'll change this to 6 and this value to 19. Okay, so this is how it looks like. I can check here. This is the diagram. Now here I can see it is 10 kilonewton and this is also 10 kilonewton. So if I look here, this red value is approximately 10 and blue is also 10. So this is showing my 10 kilonewton values above and below. If you want to see the other results, you can go to list results, reaction solution, all items. Okay. So here I can see Fx, Fy, Fz, the moment in X, Y and Z direction. Also, if I want to see the nodal loads, okay, so these are going to be the nodal loads for all the nodes over the beam. So with this, I end the session. I hope you have understood how to plot the shear force and bending moment diagram for cantilever beam. If you have any doubts, please write to me in the comment section. See you in the next session with another numerical. Thank you.